Hello, all of you wonderful mathematics souls. We are going to be creating an adding and subtracting fractions and mixed numbers foldable today. So we're going to start with some formatting. You should have received a half sheet of paper. You're going to take that half sheet of paper and look at it vertically, so up and down. And then you're going to take that and fold it down, but not all the way. You want to leave about an inch of space from the bottom of that fold to the top of that fold. So I'm even doing maybe a tiny bit more than an inch, or maybe right at an inch. And then go ahead and fold that down. So what you should end up with is this little space to leave a label down here. Then go ahead and grab a pen or a pencil, and we are going to mark that edge with a line. You can just trace it nice and neat, nice and straight. And then what I want you to do is open it back up, and I want you to fold it in half vertically. So what you may have heard in the past is that would be fold it in half hot dog style. So that would be vertically. And then I want you to open that back up. That should have created a halfway mark right between that line that you already created. And I want you to go ahead and mark that line. So I'm just going to draw a line all the way from the top of the page down through my label, where my labels are going to go at the bottom. You should kind of have an upside down T. Next, I want you to take the other fold that you already see in the middle-ish, and I want you to go ahead and highlight that fold as well. So now I have my formatting done on the inside. Here's what it looks like. Sorry, I'm trying to get the whole thing in this frame of the video, but it's not really working. So hopefully you can figure out what I'm doing. All right, we're going to focus first on the top and these labels. So let's start with these labels. On the left side, we're going to label it adding fractions. Adding fractions and mixed hashtags. Okay, JK, it's not really hashtags. That is the symbol for number, so you may see me use that. Although hashtag adding fractions is amazing, would be cool. This is really just the symbol for number that I'm using. On the other side, I'm going to label that subtracting fractions and mixed numbers. We're also going to work with a little bit of whole numbers. Now, I don't want you to put a line down here in the middle. That's purposeful that I have not done that. We're not going to put a line there. Instead, on the top, these follow the same rules. They really follow the exact same rules. So up here at the top, we're going to write the rules for adding and subtracting fractions and mixed numbers. So our number one rule, definitely number one, this is different from multiplying and dividing fractions. For adding and subtracting fractions, you have to find a common denominator. That is number one, must be done. Find a common denominator. And the reason we do that is in order to create equivalent fractions. So we're going to add that to the rule here. You're going to find a common denominator to then create equivalent fractions. So I'm just going to write to create equivalent fractions. So at this point, I have new fractions. They are equivalent to my original fraction, but now I'm looking at them broken into the same amount of parts with a common denominator. The second step is that you are going to check out the numerators. Now that we have common denominators, we are going to add or subtract the numerators only. Add or subtract the numerators. and you are going to keep the denominators the same. Now this could go along with step 2. I'm going to add it as a step 3 just because it's a different thing you're doing, but they kind of work seamlessly together. Step 3 is that you're just going to keep the denominator the same. Keep the denominator the same. You could also just keep the denominator the same, then add or subtract the numerator. So these kind of mix in together however you want to do them. And then number 4, which is a huge one. I've seen tons of students make this mistake, and it's just a sloppy mistake. We forget about the whole numbers. So I want to put it on here as a rule or as a guideline. So you want to check your whole numbers. It's very easy to get caught up in finding common denominators, adding and subtracting numerators, keeping denominators the same, and then you totally forget about the whole numbers and the whole thing's wrong, which is silly. Number 5, another huge way that students miss these problems. They forget the very final step, which is 2. I'm sure you could guess it. Simplify. You must simplify any fractions that can be simplified at the end. You must also change any improper fractions into mixed numbers. So I kind of wrap this all up into the rule of simplifying. So now we're going to open this up and we're going to do a little cut. What I want to do, and this you may find this a little interesting because I'm actually going to have you cut right down the middle of the rules that we just wrote. So if you open this up, I'm going to cut this top flap down the middle. I'm gonna turn mine upside down because that helps me. So now my labels are upside down and I'm just gonna cut straight to the first crease. I don't want to go past that. I'm literally cutting exactly where I just wrote. So what that does for me is I can still see my rules really well. It doesn't really affect that at all, but I could just focus on subtraction if that's what I need to look up, or I could just focus on addition if that's what I need to look up. We're going to start on the addition side. So if you will flip your addition flap up, we're going to start on this top rectangle and work a problem together. The first problem we're going to work is 5/6 plus 7/8. So we're just going to look at a quick problem with just proper fractions. Now, I am going to solve these vertically, so up and down. If you have a different way to do it that you know, you're welcome to do it that way, but maybe just for this foldable, you do it the way that I'm about to show you. So first I'm going to rewrite these as 5/6 over 7/8 because I just like to look at them. I like to make my common denominators next to them so I can see them together. So that's kind of the format that I use. And I have to ask myself, what's the first thing I need to do? Oh, I need to find a common denominator because I know that I'm adding fractions. So I'm going to find common denominators to make equivalent fractions. And I have to think about 6 and 8. What do I know 6 and 8 both go into? Well, if I think about my multiples, I know that it will be 24. So my common denominator is going to be 24. I'm going to go ahead and create new denominators of 24. And I want you to show what you're going to use to make these equivalent fractions. Because I need a number that is equivalent to 7/8, I need to multiply by a whole number. So 8 times 3 is 24. So whatever this has to be a whole number, I have to make this a 3 as well. So 7 times 3 is 24. And I'm sorry, 7 times 3 is 21. So now I know my numerator is 21. 6 times 4 is 24. What you do to the bottom, you must do to the top because that creates an equivalent fraction because you're multiplying it times 1. 5 times 4 is 20. So if I have my new numerators, 20 and 21, and you could also use that to compare fractions, now I know that 5/6 is a little bit smaller than 7/8. I'm going to go to my next step. My next step says add or subtract the numerators. So let's look back at this problem. I'm going to just look at these numerators and I'm going to add them. That is going to leave me with 41 over 24. Awesome. So let's check out the next one. It says keep the denominators the same. Wait, I already did that because they kind of work seamlessly together. So my denominators are not added, just my numerators. And you might want to make a note to yourself that these two are added. That's it. Denominator stays the same. And then it says check your whole numbers. Well, my whole numbers are non-existent because we are currently adding proper fractions. I don't have to worry about that one. So of course my last idea is to simplify. There's not anything that 41/24 can technically be simplified by, but it is an improper fraction, and we work with adding and subtracting fractions and multiplying and dividing. We need to leave our answers in mixed numbers if needed. So this improper fraction needs to become a mixed number. 24 fits into 41 one time, and then because it's only one, I can just subtract these. What I'm left with is 17 out of 24. I look one more time to make sure that there's not anything here that can be simplified. 17 is a prime number and does not go into 24, so this is a completely simplified answer. Let's do another one. This time we're gonna pop in some actual mixed numbers. So now we're gonna have some whole numbers at play. I have 2 3/8 plus 1 and 3/4. So again, I'm gonna write these vertically. 2 3/8 plus 1 and 3/4. Now, a common denominator that I could use could be 32 if I multiplied these, but that's super silly. We need to think of the least common denominator here. So I'm going to just say, how many times can 4 go into 8? Or is there a smaller denominator I could use? Well, 4 does go into 8. So 2 3/8 is good to go. I only need to change 3/4 into 8ths. So if I'm going to do that, I know 4 times 2 is 8. So I need to do 3 times 2 to get 6. Now I have an equivalent fraction, and I've shown my work to prove how I received that fraction. Now I can go back and just add the numerators. So you might make yourself a little note that that's going to be addition. 6 plus 3 is 9. And then you keep the denominators the same. They are 8s, so I'm going to say that's 8. Well, this is improper, so that's not going to work for me. I need to make this a mixed number. I know that 8 goes into 9 one times, and I'm left with 1/8, and that's your answer. That's not your answer. We need to be careful here, and this is a mistake I see a lot. Don't forget that we need to check our whole numbers. If you don't check your whole numbers, the whole thing might be wrong, even though you have all of this beautiful work. So let's check our whole numbers. I still have this 2 and 1 that I need to figure out. So technically, what you're going to do is you could bring down the 2 plus the 1 plus the 1 and 1/8 and add those up. So that's 2, 3, 4, 4 and 1/8 is the actual answer and not 1 and 1/8, but you better believe that's going to be a multiple choice answer if you have a multiple choice test. Be super careful with your whole numbers. Let's do some subtraction. So I think there might be a few things that are a little different in subtraction for you guys that I want to hit. So the first thing we're going to do is actually subtract a whole number and a mixed number. So in this example, we are going to do 15 minus 7 and 6/9. 15 minus 7 and 6/9. We're going to keep the same format we've been using. So I'm going to go ahead and say 15 minus 7 and 6/9. Number 1 rule, I have to have common denominators if I'm adding or subtracting fractions. Well, this is where some students get a little confused. There's not a fraction for 15. So how am I supposed to do that? Well, some students make the mistake of just bringing down the 6/9. This doesn't work because I cannot take away 6/9 from something that doesn't exist. This is basically 0. If nothing's there, it's 0. So if that's 0, I need to give myself some fractions. Well, just like we regroup in normal fractions, you can actually regroup in subtracting fractions. So you're going to borrow from the whole number. Now, some people just cancel out the 5, but I like to just borrow from the entire whole number that's visible. So I'm going to go ahead and borrow from the 15. I'm going to borrow 1 whole. If I'm going to borrow 1 whole, then I'm going to be left with 14. Well, I can't just have 14. I need to have 15. So in order to have 15, I need to put a fraction here that represents that whole that I borrowed. And I want them to have common denominators. So what I'm going to do is be super smart and use the denominator that I'm already given. So if this is a 9, I'm going to go ahead and make this 9/9. Now I have my common denominators, and I don't have to worry about going through the hustle and bustle of finding a common denominator. What's also cool about this is I'm good to go. I can subtract, not add, my numerators. So you might want to make yourself a note that you're subtracting, and that's going to give me 3, and then the same thing as before, 3/9. Don't forget your whole numbers. 14 minus 7 is 7 and 3/9. So we're done. JK, got you again. We're not done. This is not simplified. I have a fraction that can be simplified by 3. So if I simplify this by 3, the actual answer you should receive is 7 1/3. If you're confused about that, I divided the 3 and the 9 by 3 to get 1/3. So that is something you're definitely going to be seeing. So keep that in your toolkit. You can always pop this open if you need to look and re-look at what we did if we had a whole number minus a mixed number. One more example, and this is the big head honcho of them all. We are going to subtract 2 mixed numbers, and we're going to have a little funkiness happen while we're doing it. So let's check out 2 1/4 minus 1 5/6. So disclaimer, I do want to say this part. You could create these into improper fractions and then simply find common denominators and subtract. It would work perfectly fine. The reason I don't love that is because the fractions sometimes get huge and there's big old numbers you have to simplify and it just gets a little messy. But that is definitely an option for you. If you like those big numbers and don't mind, you can make these improper, subtract them after you have a common denominator and you're good to go. I'm going to show you a different method. So instead of that method, I'm actually going to, well, start with common denominators. So I have 2 1/4 minus 1 5/6. Gives yourself a little bit of room here because I'm going to do a couple things here. Common denominator. Well, I know that 6 and 4 both go into 12. That is the least denominator I can think of. So I'm going to go ahead and make equivalent fractions with a denominator of 12. This is your foldable, so this is a place where you go to see all the work that got you there. So you do need to show all the work along the way. So 6 times 2 is 12, 5 times 2 is 10. I'm showing how I got that. 4 times 3 is 12, 1 times 3 is 3. Now I have my new fractions and I need to subtract. Here's where things get a little crazy, and you gotta notice this, you have to think about it. I need to take away 10/12 from 3/12. Well, if this was pizza and I needed to take away 10 slices from a 12 slices of pizza, could I do that if I only had 3 slices? No, this is impossible. I can't do this. Just like it's impossible to take away 6/9 from something that's not even there. So I have to make it work by regrouping. So again, we're going to borrow from the whole. I'm going to borrow from this 2 and I'm going to make it a 1. And that way I've taken a whole out of it and I can actually now add that whole to this fraction. So I'm going to show it to you in a way so that you see the work and then we'll talk about something else you can do with that. I am going to add the whole 12/12. Now remember up here, we gave ourselves 9/9 because we needed a common denominator. So if I need to add a whole to this in order to make it larger to be able to subtract, I'm going to use 12/12 because my original denominator here is 12. So I hope that makes sense. I like to put this in parentheses so that I don't accidentally subtract the 12 and the 10, which I've seen students do before. This is going to give me 15/12, and this now is giving me the opportunity to be able to subtract. I can take 10 away from 15. Let me show you something, or just explain to you something that some of my students have done in the past, and it's something you'll probably want to do and get comfortable with. Instead of showing all of this work, what students do is typically say, I'm going to borrow 1. I know that's going to need to be 12, so they just add 12 to 3. And that is what I'm showing you here, but they kind of do it mentally. So 12 and 3 make that 15. So they would just write the 15/12. Okay, now let's get this going. So we can subtract now. We're going to subtract 15 and 10. I like to circle the numerators just so I'm staying organized. It's all about organization. And that is going to give me 5/12. But don't forget those whole numbers, especially when you're doing all of this. Go back. 1 minus 1 is 0. So in this case, I am done, and my answer is 5/12. You may want to make yourself a note here just so you're remembering the whole numbers, that 1 minus 1 is 0. Another thing I want you to actually do is I want you to put a star where you showed that you borrowed from the 2. So many students are comfortable adding that 12 and the 3, and they just do it. But they forget that that 12 and 3 is because you borrowed a whole. You cannot borrow a whole without showing it, and 1 and 5/12 is a typical answer we would get here as a mistake because they forget to show that they borrowed. So that's just something that you need to be careful with. So that is your foldable. You can go ahead and get that glued into your notebook, and remember to reference back to it anytime you're doing adding and subtracting fractions or mixed numbers so that you don't make silly mistakes along the way.